wait for,
Yes,
let us
sir?
wait for 5 minutes, I suppose.
Yeah.
No?
Okay.
Is it okay, Rahul?
Yeah, absolutely.
It's only 16 participants.
Yeah.
They will
They
start.
will keep on joining. They will keep on joining.
Let us keep take 5 minutes and then we can start.
Yeah.
राहुल जी
बोलिए।
आप बैकड्रॉप क्यों नहीं डाला आईपीए का?
बैकग्राउंड भेजा नहीं संतोष ने, इसलिए नहीं डाला। I'm the last minute thing, na? So
Hello, Sanjay.
sir.
Arey Baba, he's in a firefighting mode. I told him yesterday he is not the speaker. त्यांनी ऐकलं तेच आपलं नशीब आहे. He has wholeheartedly accepted and he has chosen the same subject.
He is a great support, sir. I'm just joking with him. You also don't have that background.
yeah, you should.
No, there is some problem whenever I go with that. It looks odd. That is why I don't go with the banner.
Yes.
Correct. Other meetings you can't use that.
Yes, while doing the movements, it is sometimes it is invisible or there is a reflection.
Very
If you don't adjust properly, there will blur on your head, you know, if it touches the top screen.
No, when you are moving your hand, then also there is a problem. It's not the smooth movement.
I know. I think 21 now. Yeah.
I think we should start at 5:05.
5:05. Correct. We should.
Yes.
Santosh, we should start, I suppose. It's 5:05. Let us start. Let us not wait anymore.
Good evening, everyone, and welcome to today's webinar. I'm your host, Santosh Sharma from IPA Headquarters, Delhi. On March 14th, we had a wonderful session with Mr. Mukesh Asija on the basis of plumbing. And yesterday, we had a session with Dr. Sunil Kute on career opportunities in plumbing. I hope the session was informative and everyone enjoyed it. Now, I would like to show you a video of WPC Chairman Tom Bingley in which he highlights World Plumbing Day and why the plumbing profession is important.
Happy World Plumbing Day. I'm Tom Bigley, World Plumbing Council Chairman and Director of Plumbing for the United Association
Not visible.
of Plumbers and Pipe Fitters from the United States
Yeah.
Your screen is only visible, not the video.
Just a second, sir.
In
Now
Canada.
it's visible, sir?
On March 11th,
No.
every year,
No?
people from all over the world will celebrate World Plumbing Day. This all started 12 years ago when the WPC established this date to bring awareness to the public that plumbing cannot be something we take for granted. We want to show our communities the responsibilities that plumbers have in protecting their health and, more important, educating them on ways to conserve our dwindling resources for the future. I'm here today at my nation's capital, Washington, D.C., at the United Association of Plumbers Local 5 Training Center. Here in the lobby of history are some of the early plumbing systems of this city. Although our country is young compared to the plumbing systems of India and Europe, our infrastructure is crumbling and in need of repair and replacement. That's why I chose today's location for World Plumbing Day's message. If we want safe, reliable drinking water and proper sanitation, it all starts here with training the next generation of plumbers. Every year, young adults from all over the world must decide on a career path for themselves and their families. It is essential that we promote the plumbing industry as a profession to ensure that we can continue to provide a good quality of life for the next generation. Here at the Plumbers Union, we take over 10,000 new apprentices every year at over 250 state-of-the-art training centers like this one that are scattered around the United States and Canada. These classes not only include waste, vents, and water systems, but also medical gas, backflow prevention, safety curriculums, and water reuse. Here in the rainwater harvesting training module, this facility captures all the rainwater and repurposes this for the flushing of water closets, urinals, and all the water to supply the wet training laboratories for teaching. By facilitating the training needs of our contractors and end users, we are expanding their employment opportunities, which makes it a clearer career choice for the next generation of workers. Fair wages and benefits, continuing educational opportunities, and not to mention a safe workplace environment will continue to attract critical workers for the future. It's 2022, and we are talking about the pandemic, which has killed close to 6 million people, and yet we are silent on the fact that over 800,000 people die every year from inadequate water, sanitation, and hygiene. World Plumbing Day raises awareness of this terrible but preventable statistic, but more needs to be done. The perception of good plumbing deserves to be recognized as a frontline solution to preventing diseases from taking away the lives of our children. Here at the World Plumbing Council, we work with global organizations like the World Health Organization, Messe Frankfurt, IWISH, and the World Skills Competition to support new technology and training seminars that promote clean, sustainable water and sanitation. To increase our voices, we need your help. Get involved by joining the World Plumbing Council. Share a link on your Facebook page or request proclamation from your country that recognizes March 11th as the World Plumbing Day. The more publicity we get, the more attention will be drawn towards funding to build critical plumbing infrastructure throughout the world. Also this year, the World Plumbing Council Conference will be hosted by China in beautiful Shanghai on October 13th to the 15th. Please join me and our entire World Plumbing Council family in exploring new products, new technology, and plumbing practices. The world is a small place. We must all work together to preserve our resources for our children and their children. Help me in celebrating World Plumbing Day by thanking all the plumbing installers, the plumbing manufacturers, the supply house workers, plumbing engineers, sewage and water treatment plant workers, and especially our plumbing instructors, for without their sacrifices and efforts, we would not be able to train the next generation of skilled plumbers. Thank you, and remember that the plumber protects the health of all nations.
Happy World Plumbing Day.
Thank you for listening. Now, wherever you are, let's all stand for the national anthem.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
So, before we go further, I would like to express my gratitude to everyone who has taken the time to join us today as we discussed about good plumbing practices. Throughout the session, your active participation is important. So I would like to request you all, please be on mute so others are not distracted by the background voice. Now, I would like to invite Mr. Sanjay Bilare, Chairman of IPA Hyderabad Chapter.
Thank you, Santosh. Good evening and welcome all participants in today's webinar. IPA is celebrating World Plumbing Day and IPA Founders Day through all IPA chapters across India. IPA is organizing variety of programs like drawing and painting competition on safe water in schools and colleges, blood donations, webinar series, regional webinars, plumbers meets, and some other events. IP aims to bring awareness in professionals like engineers, students, architects, project managers, consultants to use the codes and standards in plumbing practices through UIPC, supplementary codes, a guide to good plumbing practices, webinars, events, etc. The major event like IPPL, which is knowledge sharing training program by eminent and experienced plumbing fraternities every year. For 6 days program, there is a 6 days knowledge program. Every chapter is conducting IPPL in their own respective chapters to train the professionals. There is a IPC conducted every year, which is a national conference with plumbing product exhibition and conference is organized again every year in different parts of the country. Plumbex is plumbing product exhibition showcasing most of the products where manufacturers display their existing products and newly launched products. I Save Water mission is to save millions of liters of water through water saving products in domestic areas. The first plumbing lab in Pune Engineering College gives physical feel of all the plumbing products installed, their functioning and feel of inside wall, outside wall, shafts, underfloor piping, etc. gives thorough knowledge. All these programs are initiated under the dynamic leadership of our President, Mr. Gurmit Singh, and stalwarts from IPA family. Students who are skilled in driving innovation and have the technical expertise in plumbing to work on variety of projects where one can get opportunities, ample opportunities to become design engineers, project managers, contractors, MEP consultants, which is vital in building industry. Today we have Mr. Subhash Deshpande, a plumbing engineer and green plumbers trainer as a speaker to elaborate on good plumbing practice. I think that's it from my side. You can take over, Santosh.
Yeah. So I would like to inform you that Mr. Subhash Deshpande was unable to participate in today's webinar due to the throat infection. So and he was very disappointed that he would be unable to join us today. So, but in place of Mr. Subhash, we have a skilled, knowledgeable, and experienced person, Mr. Rahul Dhadphale, our IPA National Secretary. He will spoke about the good plumbing practices. Now let's move on. I would like to over to Mr. Milind Shetty, Chairman of IPA Nasik chapter and the student chapters convener. He will share the opening remarks.
Okay. Very good evening and a very warm welcome to all the students and present delegates on this webinar, which is on the subject good plumbing practices. Dear students and delegates, this is the third webinar in the series of fourth webinar. Santosh, am I audible?
Yeah, you are audible.
I'm audible, is it? Okay.
Yeah, audible.
So this is the third webinar in the series of four webinars that we are organizing to celebrate the World Plumbing Day 2022. Friends, good practices are important for processes that you need to work correctly. They are simply the best way to complete the plumbing work and have been worked out through trial and error and are found to be the most sensible way to proceed the work. These good plumbing practices are designed and defined by national and international expert teams after spending hours in analyzing pros and cons with the aim that the work can be done better, faster, more efficiently, and with fewer problems and mistakes. We at IPA have a technical committee which comprises of all the stalwarts, technical experts in the field of plumbing who work on all the codes and standards and have published various codes including UIPCI, that is Uniform Illustrated Plumbing Code India, along with a very, very handy book, informative book, which is called as A Guide to Good Plumbing Practices, which can be referred by you all to understand the good plumbing practices in a better way. Now, whenever I talk about plumbing and good practices, I always have a question. Why should we follow the good or the best plumbing practices? What is good in that? It's a simple work. And here is where we are mistaken, always mistaken. We take plumbing very casually. See, the plumbing installation have a direct impact on the health of the occupants, the health of the structures which you reside or which you occupy. Health means it may be the life of the structure, the stability of the structure, and so on. And also plumbing has a direct impact on the environment. Actually, if you see, or if you now consider about the health, then you will see that almost all the diseases that exist on the earth, almost 65 to 70% of the diseases occur due to just due to water related issues. Maybe either due to scarcity of water or consumption of polluted water, or maybe due to improper disposal of wastewater, etc., etc. I will not go in detail. Now, when we talk about the health of the occupants, good plumbing, according to me, is the first line of defense. It always should be plumber first, doctor next. Because if you see, the doctor cures the diseases. but the plumber prevents it. And so good plumbing installation will protect the health of the occupants and prevent them from falling ill. And that is why good plumbing practices are very, very important. There are many, many cases where faulty or incorrect or bad plumbing has resulted into epidemic or large, what you can say, illnesses in many areas. One classic example I would love to give here is SARS. The SARS disease erupted just because of incorrect installation of the trap in the bathroom. Imagine a simple trap, if not fitted correctly, can create havoc. And you will not imagine, due to SARS, thousands of people had to lost their lives because of the infection that was caused to the occupants in that area. Normally, if you see plumbing systems, when you see very casually, it may appear static as compared to the other mechanical systems, but they also involve significant engineering challenges. A poor design and installation process can create issues, big issues, which will be very dangerous. For example, if a high-rise building, the water supply systems are not designed properly, the water hammers may occur in the pipeline, which in return may burst the water supply pipelines. Improper and adequate venting can create backflow of sewage in the habitable premises or maybe back siphonage. Corrosion can cause leaks, and besides this, blockages in drains, leakages and seepages will damage the structural members or the building and reduce the life of the building to a large extent. Dear students, all these problems are very, very dangerous to the building life and also to the occupants who live in the building. So I would urge you all to listen to our today's eminent speaker, Mr. Rahul Dhadphale, on this very important subject, good plumbing practices. That is it from my side. Over to you, Santosh. You are requested to please introduce Rahul, and then Rahul can talk over. Thank you. Thank you very much.
Okay. Thank you, sir, for sharing the valuable remarks. First, I would like to play the sponsorial video.
Is Veerappan joining?
Not yet, sir. He will join after some time.
Okay, fine.
KPT, Flow Infinite. Modernization is an indispensable aspect for any society to thrive, grow, and develop. Rapid urbanization requires robust infrastructure development and building construction. Every industrial and commercial construction requires a non-corrosive and eco-friendly advanced plastic piping system. Here comes KPT Piping Systems Private Limited, an ISO 9001:2015 and ISO 14001:2015 certified company with the advanced European technology PPR piping system. Operational since 2008, KPT is India's #1 industrial PPR piping solutions provider. A leader in polypropylene random copolymer piping systems, PPR Piping System has a state-of-the-art multi-specialty piping manufacturing facility and uses non-toxic food-grade, highly strength, fusion weldable raw material for the production of its piping systems. To ensure world-class quality, KPT brings to you a piping system made with R200P PPR raw material, 100% Hyoseong from the Republic of South Korea. PPR pipes are eco-friendly and 100% food-grade material and resistant to most of the chemicals. PPR piping system is now widely used in the fields of drinking water, compressed air, cooling towers, firefighting, acids, RO, DM, ETP water applications, offering a longer lifespan of 50 years. With world-class PPR raw material and state-of-the-art production facility, KPT has successfully completed 2,500 plus complex projects for various industrial, commercial, and government organizations. Our piping system is now running for most critical applications like data centers, injection molding factories, and chillers all over India. Our product ranges: pneumatopipes for compressed air, green therm for water applications, thermoplast for firefighting system, KPT's manufacturing facility, lab, infrastructure, etc. KPT has a full-fledged and fully automated manufacturing facility with a capacity to produce 15 metric ton pipes per day. The unit has a fully equipped lab for material testing and quality assurance. The company adopts a stringent quality control process to ensure our customers get only the best anytime and every time. Our achievements: winner of India 5000 Best MSME Award for outstanding contribution in quality and excellence in the realm of customer satisfaction. Pride of Bharat for the year 2021 for the most trusted pipes manufacturer and suppliers of the year. Our esteemed members: FIEO, Federation of Indian Export Organizations; CII, the Confederation of Indian Industry; EEPC, Engineering Export Promotion Council. We believe innovation and quality are the key to deliver world-class products. For over 13 years, we are working to deliver excellence to all our stakeholders. KPT, Flow Infinite.
So let's move on. This year, in addition to student webinar, we organized regional webinars in Malayalam, Tamil, Telugu, Kannada, Marathi, Gujarati, Bengali, and Hindi from March 2nd to March 10th. On 11th March, we held a national webinar to celebrate World Plumbing Day. This recorded webinar is available on the IPA website under virtual technical sessions. Our social media contest is still open until March 17th on these 4 aspects: reuse of water from RO reject, fixing leaks, reduce water footprint, other innovations, daily chores in kitchen and bathrooms. You can share your experience and case studies. We have a standard format that you may see on our social pages, and you can share your experience as entry on our Gmail acep@indianplumbing.org on other social platforms. So you have the 4 social media platforms to submit your case studies and experience, and the top 3 will get the cash rewards. So hurry up, you haven't ruined your opportunity yet. Now, I would like to introduce our speaker. His name is Mr. Rahul Dhadphale, our National Secretary. Rahul Dhadphale is the Director of Ujjwal Consulting Private Limited, Pune, a plumbing consultancy firm. Mr. Rahul Dhadphale has done postgraduate diploma in piping design and construction. Under his able leadership, Ujjwal Consultants has successfully completed more than 1,000 plus design projects all over India and abroad in last 31 years. Mr. Dhadphale is also the National Secretary of Indian Plumbing Association and the National Convener of the World Plumbing Day and the member of IPT Editorial Board. Now, I would like to invite Mr. Rahul Dhadphale.
Thank you, Santosh, and welcome all students to this third session in the series of 4 webinars for specifically students. And today's topic is good plumbing practices, do's and don'ts. What exactly is the good plumbing practices? You should understand the subject first, and then you should understand what you should do and what you should not do. So here you will find this information. The reference codes and books are Uniform Illustrated Plumbing Code, Water Efficient Products India, and a book called A Guide to Good Plumbing Practices published by IPA. So whatever information is given, if you really want to see it in books, you can refer these 2 codes and 1 book, A Guide to Good Plumbing Practices. Now, first part is you should know what exactly are the setting distances. Whenever we are basically designing or planning any toilet, we should know what should be the minimum distances which are kept. Suppose it is a wash basin, then from wall you have to keep minimum distance of 400 mm. In between 2 basins, it should be 800 mm. If there is a one water closet, the center of water closet and center of wash basin, it should be 800 mm. Accordingly, if you go on putting the distances, then what should be the minimum area in a toilet you will be able to arrive at. So there are specific distances in between 2 urinals, it is 600 mm. Center of urinal to wall, it is 350 mm, and so on and so forth. So to accommodate a commode, you require minimum 1,500 to 800 mm of space. So accordingly, you can plan your toilet. Now, these are basically the standard heights. These standard heights are basically related to the height of a person, and depending on the height of the average height of the person in that country, this may little bit vary. So now if you see the shower head, from the bottom it should be in between 1,800 mm to 2,100 mm. Your mixer 750 to 1,000 mm should be 375, should be 400 to 450. The bottom of the urinal should be 600 mm above the floor. So these are the basic distances as well as standard heights which you have to maintain in any toilet. You cannot, you can have more than these values, but you cannot reduce it. Now, at the same time, there are certain maximum flow rates which are permitted as per the codes. Now, if you will see, these flow rates are given at 4 bar pressure. Lavatory or faucet, public non-metered, it is 2 liters per minute. 2 liters per minute. Lavatory faucet, public meter, it is 1 liter per use. Lavatory faucet, private, it is 8 liters per minute. Shower head is 10 liters per minute. Handheld shower 10 liters per minute. Sink faucet 8 liters per minute. Handheld bidet spray 8 liters per minute. Water closet 6 liters per flush, and urinals 3.8 liters per flush. Now it is mentioned that it should be at 4 bar pressure. Now normally when we design any system, the pressure rating is maintained between 1 kg to 3 kg. So what exactly it means, if the maximum flow rate is given at 4 kg pressure, whether it means that at design pressure, it will give even the lesser flow rate than that, that is not the case. So there are certain aerators. Now you all know, when you introduce any aerator, it will mix the air with the water and it will break down the water in small particles so that this water will not splash on your body and there will be a water saving. Additional one, it is called PCA, that is a pressure compensating aerator. Now this pressure compensating aerator will compensate the pressure or will adjust the pressure and will give you constant discharge in a particular band of pressure. So if you are designing your system in between 1 kg to 3 kg, this PCA, if it is selected for 8 liters per minute, it will give 8 liters per minute irrespective of the pressure. So within your band of 1 kg to 3 kg, you will get 8 liters per minute only. There will be no difference. There will be no reduction in the flow rate. So aerators basically are used to save the water in first place. And if you increase the pressure and don't introduce any air, this water is going to splash on your body. So unless and until you break down the particles of this water, this will splash. If you break down along with the air, there will be, you will find the bubbles on your hand.
Sorry to interrupt, sir, but your shared screen is visible, but your picture is not visible.
My picture is not visible.
Yes, sir.
Santosh, it is visible to me, not an issue.
Okay, okay. It is not visible to me. Okay, not an issue, sir. Please carry on.
The participants can type in chat box if they have any issues.
So, toilet planning. Now, toilets are planned in 2 different ways. One is sunken portion and non-sunken floor. So, this is a sunken portion. So, this is your normal slab. You take a sunk in the toilet, and in this particular recess, you place entire your piping. But in non-sunken floor, your slab will be almost on the same level. You just take it down by 2 inches so as to accommodate the chemical waterproofing. So your sunken portion will be only of 2 inches. And entire piping will run below the floor. So if this is a toilet, the piping will run through the top of the toilet at the bottom floor. So to hide this particular piping, you will always have a false ceiling. So entire piping will be running in between the false ceiling and slab. There are normally in India, in most of the cases, we are using the sunk floors. But nowadays, even this ceiling hung or non-sunken floor piping is getting popular. So there is certain advantages in non-sunken kind of a piping. Whenever there will be a leakage, the leakage from top floor will always be experienced or failed at the bottom floor. But when you have a sunken floor piping, unless and until you get the cooperation from the top floor person and he allows his toilet to be broken and redone, and it will take almost 15 days. So unless and until he cooperates with you, you will not be able to maintain this particular problem, or you will not be able to address this particular issue. But in non-sunken floor, still any leakage will be experienced at the bottom floor only, but you can open your false ceiling and you can address any leakage if it is, and you can repair it without any cooperation from the top floor. So these two are different kind of piping layouts, and how the piping is to be routed. Waterproofing methods are different, but ultimately, if you are going for single stack system, or if you really want to accommodate a water seal of 50 mm, which we are going to discuss, that minimum water seal should always be 50 mm. And if you want to accommodate the water traps, which will have 50 mm of water seal, the depth of the sunken portion should be 450 mm. Normally, we are doing piping in 8-inch sunken floor. Therefore, the Nani trap which we provide doesn't have the 50 mm of water seal. Therefore, we take two separate lines up to the ground. We provide a gully trap which is having a 50 mm of water seal. We connect our 3-inch pipeline where we are not in a position to give 50 mm water seal. So this particular pipeline will get connected to gully trap. There is a 50 mm water seal, and then that gully trap will be connected to the chamber. Whereas any commode, any line from the commode, that is 4-inch line or soil line, will directly come down to the ground level and will directly connect it to the chamber. So that basically is the difference. Now, there is a concept called wet area and dry area. So if you really want to implement this wet area, dry area concept, it is compulsory that your shower should be in one corner and preferably near the shaft. You cannot take any wet area. If you are going to follow the wet area, dry area concept, you cannot have your shower at the center of the toilet. So this is a wrong method of planning. This is a right method of planning. Now, there is a requirement of ledge wall. Now, in section, you can see this is a beam. So, if you don't take any ledge wall, this pipeline you will be routing through the wall and you will directly come on the beam. So, either you will have to break the beam to enter into sunken portion, or you will have to take a ledge wall so that you are preparing a room for routing of the pipeline. So this pipeline will be directly entering into either sunken portion or the ceiling hung type of piping. Still, you are not breaking or you are not disturbing any RCC member in your toilet. If you see here, there should be a cutout. There should be a working platform. Nowadays, most of the buildings are high-rise building. Number of floors are too much. So to maintain the piping systems, you have to provide the working platform. Now, if you provide the working platform in this particular fashion, the additional requirement is there that if there is a working platform like this on each and every floor, you will not be able to access this shaft either from the top or from the bottom, because they everywhere this working platform will hinder your movement. So in your toilet, whatever window you have, it should be openable window and you should get the access through this window. So you will enter in your shaft, in your work on your working platform through your window, and then you will maintain this particular pipelines. So this is shown. This is a openable window so that one will access this shaft within the toilet itself. He will come on the platform, and this is the recess from which the pipelines are routed, and sitting on this platform, he will access the pipelines, maintain the pipelines, he will address the leakages in the pipeline, and he will do all the maintenance work. Now, if you see, this will be seen like this. So this is a recess in the platform through which the pipelines are running, and there will be access only through, because person cannot go up and down through this small opening. So only way is to access this through the toilet only. And therefore, while doing the planning for a trapdoor or a openable window is a must. Now the traps, whatever we see in commodes, that water is nothing but a trap. And what exactly is the trap? This trap is the barrier in between drainage line and your toilet or in your living space. This trap will ensure that no foul smell, no foul gases, or any bacteria or viruses causing any kind of disease will be able to enter in your living space. If this seal is broken, then there is no difference between your living space and the drainage. And therefore, you will always find a very different kind of smell in an empty flat. Because in an empty flat, this water will get evaporated and all kind of foul smell will enter into living space and it will be sprayed over there. So this seal, if you see, the seal depth is this. Water cannot rise above this because the water will start flowing in this pipe. So this particular level, that is upper deep, to the trap arm bottom or the crown wear is the seal depth. And this seal depth must be minimum 50 mm so that any foul smell through the air will not pass through this water and will never be able to enter into your living space. Now, there are certain requirements of these traps. Fixture traps, there are different kind of traps, fixture traps and floor traps. So we have a trap in a commode, that is a fixture trap, and we use nani trap, that is a floor trap. Now, any commode or any urinal, if it is a integral part, the trap cannot be removed from that particular fixture, then it is a integral trap. And there are certain approved traps and there are certain banned traps or which are not allowed as per the codes to use. Now these are the prohibited traps. You should not use it. That is S trap. S trap is prohibited traps as per the codes. Drum traps. Drum traps can be used, but in a dental clinics or any goldsmith person, but not for any drainage application. Nani traps are prohibited traps simply because in nani traps you cannot provide any 50 mm seal and therefore it is banned trap. And the bottle trap is also banned or bottle trap is also prohibited. We will see why exactly it is prohibited. So trap for FOG, that is fat, oil and grease. So there are different kind of traps. There are traps to remove the sand. There is trap to remove the petrol and diesel. There is trap to remove the grease. And a common example is for commercial kitchen, petrol station, car parks, car wash, swimming pools and food handling establishments, you have to provide these kind of traps. Now, when you go for FOG, this grease or oil or fats, these are lighter and they will always float on the water. So you have to ensure that this oil will come here, it will float here, the water will enter from the bottom and flow. So oil will get trapped in this particular trap, and you will have to periodically skim it and remove it from the trap and clean the trap. Then waste connection to floor trap, how you are basically connecting it. So this is a wrong way. Why it is wrong way? Because you have placed the trap, and this the gap in between the floor and the trap, you have done a smooth cement finish, which is normally called ghotai, and there is a connection in that particular disease. So there will be every chance that there will be cracks and water will start penetrating and entering into the waterproofing. So if there are separate fittings, so this is an integral fitting, there is no possibility of water leaking through it and entering into the waterproofing. So you should use these kind of fittings and should not leave it to the plumber who is going to do the ghotai for your top portion of your trap. So multiple trapping has to be avoided. Means in a series, you cannot have multiple traps. There should be only one trap. Then in this particular case, waterproofing issue will be there. And there is an inlet fitting or hopper which you should use. So if you are using a trap for your basing outlet, then it should not be connected on the top of this trap. And if you are not using over there, then you can connect it to the trap. So multiple trapping should be avoided. So the summary of the trap, a liquid seal of not less than 50 mm. That is a basic requirement. Even if you will refer our National Building Code, the requirement of 50 mm seal is there. We are normally using the Nani trap, everywhere it is used, but we are using the prohibited trap. We are using the trap which we should not use. We are using the trap which does not give any safety, or it is not protecting our health. A smooth and uniform interior water. So there should not be a cross-sectional area different in different part of the water seal or the trap. So your area should be smooth and it should be uniform. It should not reduce, then it should not expand. It should be uniform throughout your trap. Then it should be self-cleansing type. So there should be a velocity that can be created, and any solids should not get settled into your trap, but they should flow along with the water and they should go in the drainage system. So these are basic requirements of any kind of a water seal or water trap design, or the requirements made of approved material. So we have to ensure that we should use only water traps which are used out of approved materials, and trap partitions to be non-removable. If there is any partition which is creating the water seal, it should be non-removable. A plumber should not be able to remove it, because if you remove any partition, there is no water seal that is left. So normally the best example is the multi-floor Nani trap. I don't know whether you have seen it, but in multi-floor Nani trap, there is a partition, there is a slit which can be removed. And if you remove that particular slit, there is no water seal. It is only a pipe which is left. So pressure in drainage stack. Now, if you know, whenever you will release any water through any fixture in the drainage stack, stack is a vertical line carrying drainage, sewage or soil water in the shaft. So this is a particular pipe. So whenever you will release any kind of water in this particular stack, it will always flow along the periphery of the pipe. It will never flow at the center. So central core will be available for air to flow. So whenever water is flowing in the down direction, air is also flowing along with the water. Because the air is flowing along with the water, it will create a positive pressure in the downstream and it will create a negative pressure in the downstream. Actually, it happens like this, that because of the gravity, the velocity will start increasing, and at the same time, this pipe surface will provide a frictional loss. It will provide the opposition for the flow. So because of the gravity, the velocity will go on increasing and it will increase to a certain extent, which is called terminal velocity. So terminal velocity is that particular velocity at which the gravitational force and frictional losses are matched. So beyond that, velocity increase is not possible. Velocity will be restricted to the terminal velocity. Now, if you add any water, if you increase the flow rate in the stack, then the thickness of this water film will go on increasing and it will reduce the area for airflow. So pressure begins to drop below atmospheric pressure, that is a negative pressure. Now, how this negative pressure will be balanced? Either if it is not vented, only the air that can be provided through the cowl at the top or the terrace level. And therefore, basically, we provide the vent system so that this negative pressure will be immediately nullified. Otherwise, it will act on any water seal which is nearby to this negative pressure area. The same way, there will be positive pressure at the downstream that will also has to be balanced, and otherwise that is also going to affect your water seal. So if you see, the water seal was balanced. Why it was balanced? Because there was atmospheric pressure acting on both sides in an equal magnitude. So unless and until there is a pressure imbalance, water will not flow in any one of the direction. So now we have seen that there was a negative pressure. So if this is a particular connection to the stack and water is flowing and this is a negative pressure, and if it is not balanced, then it will act on this water seal and it will suck, or it will suck this water from the water seal and it will be discharged in the water stack, and this seal can be broken. If the positive pressure pushes this water, it will come out of the seal, and in that case also water seal either will be reduced or will be totally broken. And if you know, entire drainage system is basically designed to ensure that your water seal is remain intact and it is never broken, because that is what is the guarantee for your health. So you have to, if you know 1 kg pressure is equal to 10 meters of height. So 10 meters of height is 10,000 mm, whereas our seal depth is only 50 mm. And any pressure difference of even 200 mm of water column can disturb our water seal. So you will understand how close tolerance is there to maintain the pressures. Now, therefore, this vent is required. Now, if this water is coming like this, if it creates a negative air pressure here, this vent system will provide the air and it will balance the pressure over here so that this water will not be sucked because of the negative pressure. So each plumbing fixture trap shall be protected against back siphonage and back pressure, and air circulation shall be assured throughout all parts of the drainage system by means of the vent pipe. So this vent pipe will be connected to each other and will run parallel to this your stack system and will be open on the top of the terrace level. So you can see, if you are giving a vent system, there are certain requirements. Now this is a trap and it is coming, this is basically the slab, and this connection is coming below the slab and then entering into the shaft. So your vent pipe will go above this highest flood level. It will go above 150 mm and then it will travel horizontal. It will ensure that your vent pipe is never flooded with the water. That is not possible because this is the highest flood level and you are taking your pipeline even above that particular highest flood level. Now, if you know, this is particularly air admittance wall. Now, air admittance wall is called active venting. Air admittance wall is a non-return wall for air. So it will not allow any air to flow out of it. But every time you will use it and your water will flow, because of the negative pressure, it will supply the air and it will balance the pressure, and that negative pressure will not act on this seal and it will not suck the water from this particular water seal. So each trap needs and vent 2 into D away from the above flood level. No crown venting. On crown you cannot vent, and you can use even the AAV if there is no space to run the vent pipes. There is a concept called indirect waste for food and beverage handling. Now suppose you are washing any food items in this particular sink. It is very necessary that you should connect it through the indirect method, because you have to ensure that even flooding of this particular trap will not pass on the contamination to this pipe, and through this pipe it will enter and it will enter to your food items and will have a very bad impact on the health who are going to consume that food. So it has to be separated out. So this is an air gap, if you can see. So you will release the water from the top. There will be no contact, so that even if this is flooded, this contamination cannot travel back and contaminate the food items. So for food and beverage handling, we have to understand that this is particularly connected in the way an indirect waste has to be connected, and trap and vent exemption is there. So there are different kind of drainage system or connection systems, and these are mentioned in NBC also and UIPCI also. So one is a 2-pipe system which is normally used in India, but what we use and what is allowed in the code is something different. Now, if you see, that there is a air venting, this particular line is a vent line, and every WC is vented and connected to this vent line. At the same time, you have 2 separate lines, one for soil and one for silage, but you have 2 separate lines even for venting. So commodes are vented and connected to a separate line, and all floor traps or basins are connected to a separate vent line. So even 2-stack system, what is required is you should vent all the fixtures. You may connect it to a single line, you may connect it to two different lines, depending on what kind of seal depths you are maintaining. So one pipe fully vented system. Now here you are connecting the commode as well as the floor trap and basin, everything to a one pipe. So there are no two separate lines. Normally we are using 3-inch line for sewage, 4-inch line for soil. And normally in India, we are only venting the 4-inch soil lines or the commodes. Here, everything is connected to the one pipeline only. Now you can do it, but it is must that each and every trap is having minimum 50 mm of water seal. You cannot use any nani trap. You cannot use nani trap and do this kind of. In any case, using nani trap is a wrong system as far as technical issues is concerned. But using the nani trap with one pipe or single stack system is even disastrous. So nobody should even think of it. 50 mm seal in any type of a drainage connections is a must. So one pipe partially ventilated system. Now here what they have done, you are connecting your WC and your floor traps to the same pipeline, but you are venting only WCs and not venting the floor traps. So this is called one pipe partially vented system. When you vent each and every trap, it is one pipe fully vented system. And there is, when we say one pipe system, there are actually two pipes, one to carry water from floor traps as well as from commodes, and second pipeline for venting. Whereas in single stack system, it is a particular system where there is only one pipe, and the pipe which is carrying the water will give you the venting effect also. So the system is designed in such a way that one pipe acts as a both water pipeline also, as well as the vent pipe also. So it provides for the flow of liquid, solids and air without loss of fixture traps. I have already told you that entire drainage system is basically designed to ensure that your floor water seal, is remain intact and it is never broken down or even loses its seal depth. It allows fixtures to be installed without vent. So here you don't have any separate vent system, but your water pipeline is acting as a vent pipe also. Suitable for Indian conditions where installing vent pipes in masonry is difficult and cumbersome. So if there is no space, then this is the best solution. Saves material, labor, space, time and cost of drainage system. And stack size is same throughout its length. So if you see, this is called aerator or sovent. So there are connections. In one connection, you can connect 3 toilets. So one 4-inch line you will connect here, one 3-inch line here, one here, and one on the opposite side. So in one aerator, you can connect 3 toilets. Now every time the water is flowing like this, it will travel and it will again come into the main line. The basic issue is water which will be connected at this particular level will first go to the periphery of the pipeline and then will only enter or get mixed into the water stream that is coming from the top. One has to understand that drainage is basically a 2-phase flow. Drainage water is flowing as compressible fluid and air is a compressible fluid. So water being a non-compressible fluid, it can flow only in one direction, that is with gravity, it will flow downwards. But air being a compressible fluid can flow in both the direction. It can go up also, it can come down also. So whenever you interject the airflow, the air gets compressed and there is a pressure imbalance in the core of the airflow, and that imbalance of the pressure is also going to act on your water seals. And therefore, if you ensure that you are not touching any airflow, your water is mixing directly into the water flow, the chances of pressure imbalances are less, and that is what is achieved in this aerator. So this particular water is coming down. Now here there is a problem that when we have discussed that water will always flow along the periphery of the water. But at the basement level, say you are turning your pipeline, water will not turn because you have turned your pipeline. So water in this particular will fall down and it will block the path for the air. So air which was traveling along with the water will get trapped over here. But being a compressible fluid, it will go on increasing the pressure, and at a certain pressure it will rebound, and what air will start flowing in the reverse direction. And therefore you cannot connect, whenever you turn the pipeline diameter into, if you can see, this is the 2 meters vertical and horizontal. You should not connect any connection because this is the zone where there is a pressure imbalance. So to release the positive pressure relief loop is provided. This is, we are talking about the single stack system. We are not talking about the 2-pipe system which is normally used in India. So if you are going for the single stack system, then only what we are discussing is applicable. So this is a pressure relief loop, and if there is any connection just above where you are turning the pipeline, you will connect it to the pressure relief loop, and so this will take care of negative pressure and this will take care of positive pressure. So therefore, whenever you go for a single stack system or even for any system, you should use a swept T and not the 90-degree T. If you see here, there is a smooth curve. So when there is a 90-degree T, water enters at the center of the pipe. So ultimately it disturbs the airflow and then it goes to the periphery. Whereas if you have a swept T, water will slide down and enter directly on the water flow which is flowing at the periphery. Even if you have back-to-back connection, there is a double fixture fitting, whereas in both the direction it is a swept T. So this care one has to take. Horizontal to vertical connection, there are certain restrictions. You cannot connect it the way you want. You have to use the proper fittings which are available in the market. You should use double fixture fittings and not connect it this particular way. So we already discussed when this will come down, this is considered as a zero velocity point, and then velocity will increase depending upon the slope that you have provided. So if you understand, if the velocity is less, the same amount of water will cover higher space area. So this is a hydraulic jump. So this water will jump to this particular level, and then because your velocity is going to increase, it will get stabilized. And therefore, to avoid this particular area and this particular area, you have to avoid 10 times the diameter of the pipe, either in vertical distance or horizontal distance. You should not connect, you should not have any connection. Then there are cleanouts. Now, what normally we have, the chambers, they are cleanout. We have a plug T, plug, all those plugs are basically cleanouts. So if you are running the pipelines in the basement like this, you have to provide the cleanouts at right locations, so as to, if there is any choking, if there is any blocking, you will be able to you will be able to put the rod and clean that choking. So the type and locations one has to be very careful about. Then hangers and supports. Now, which kind of wall clamps, brackets, hangers, support, there is a specific distance, what kind of pipes you are using, whether you are using the pipe for hot water, you are using pipe for cold water. Accordingly, also your support system and the distances are going to change. If you are going for hot water, there will be expansion, and you might have to go for the expansion loops. Now, water supply system, there are different kind of water supply system. One is gravity supply, one is pressure boosting, one is hydropneumatic systems, one is combination of the all above, and equitable distribution with zoning and PRVs. Now, if we have already discussed that normally we have to maintain the pressure in the pipelines in a particular zone. So it should not be less than minimum pressure required, because all new generation fittings, they require minimum pressure. Normally it is 1 kg. So you have to ensure that your pressure is above 1 kg. Now, to achieve the pressure of 1 kg, if you are going for a gravity supply, then your bottom of your overhead tank should be at least 10 meters high. I am not considering any frictional losses. I am considering that pipelines are sufficiently large enough so that there is absolutely a negligible frictional loss. Still, you will have to have your bottom of your tank at least 10 meters high. So that is practically not possible, and therefore in any bungalow or for top 2 to 3 floors, irrespective of number of floors in a building, you have to provide a pressure boosting system. Then and then only you will be able to achieve the minimum pressure required by the fittings. Now, if your pressure is going beyond your maximum permissible or your maximum design pressure, then you will install the pressure regulating valves, and you will reduce the pressure to ensure that anywhere your pressure will not be less than minimum required pressure and will not cross the maximum allowed pressure. Hydropneumatic system, either you can supply water directly from your underground tank by a pumping system directly to your taps or to your consumption point, or you can have a combination. If your say building is 22 floors, top 11 floors, you can supply it by your overhead tank, and bottom 11 floors you can directly supply it by hydropneumatic system from underground tank. So head, normally it is a suction head, static head, residual head, and frictional losses. Residual head is a minimum pressure required by the fitting. Now, minimum pressure required by the fitting means there will be a frictional loss across that fitting. When I say that there will be 1 kg pressure required at my fitting to achieve a 10 liters of per minute discharge. So at 10 liters per minute discharge, there will be a frictional loss of 1 kg. So normally the pressures will be maintained between 1 to 3 kg. Velocity as per the course, you should not cross 2.4 meters per second, but practically velocities are kept below 1.5 meters. Then water temperature you have to consider, and diameter of pipe and fittings you have to consider. Resources, you know, there is a municipal water supply, tank water supply from tankers, lake or rivers, treated water, reclaimed water, harvested rainwater. And tanks, either you have underground tank, overhead tanks, there will be different compartments, and there, if there is a compartment, there is a sanitary separation. If you are using a sewage treatment, if you have a sewage treatment plant and you are using treated sewage for flushing and gardening, then there should be a sanitary separation. Sanitary separation means a physical separation. You should have a gap in between the two pardis of the two compartments. Then identification of water quality. You should have these kind of stickers so that any reclaimed water one will not consume even by mistake. So joints, you have to deburr it. If you don't deburr it, then this kind of situation will be created, which will restrict or which will hamper the flow, and the smooth flow can become the turbulence, and the frictional head will also increase. Now in hot water system, there are centralized hot water system. Those are solar and boilers, and hot water heaters, instant and storage type, gas, electric, and heat pumps, or you can use the combination of the same. What you have to understand when you are going for a hot water system, that the hot water is corrosive in nature. Any deposition or corrosion will happen more in hot water as compared to cold water. This hardness which is there will deposit very fast as compared to cold water. Therefore, GI pipes are not normally recommended. It is not the case that it is not recommended anywhere, because mostly the PVC pipes will withstand 92 degrees centigrade. So if you are connecting it to the solar system, either you go for thermostatic wall and control your temperature, else your PVC pipe will fail, or you will have to have at least some portion in GI where the temperatures can go high. Then expansion of water, because of the temperature, water will expand, and this expansion will create the pressure inside the system. So you have to provide a hydropneumatic kind of a tank where the pressure, increase in pressure will absorb, and it will maintain the pressure inside the system. And you will have to provide the expansion loop for the expansion of pipes. Any hot water piping system, may be PVC, maybe metal, it has to have a insulation on it. There is no pipe where you can get away with the insulation. So it is a must that any pipeline, you can use different kind of pipelines, but you use any material for the pipeline, but you will have to provide the insulation. Hot water, you always have to provide at the left. In any mixer, hot water connection will always be on the left, and cold water connection will always be on the right. Then there are different kind of walls. Now there are isolation walls. They are known as either isolation wall or on-off wall. They are not control kind of wall. You cannot partially close it and control the flow. So ball wall, gate wall, angle wall, butterfly wall, stop wall, these all are isolation wall. Regulating wall are PRV, NRV, check wall, globe wall, TMV, backflow prevention device, and others are the gauges strainers. Now, which are the walls location? Discharge side of each water meter at each building supplied by common service or meter, downtakes or riser in each plumbing shaft for each apartment, dwelling or toilet, or discharge piping at a water tank on cold water supply at or near appliance, so that you should be able to separate it out. So if you have a pressure reducing wall, on pressure reducing wall on both sides, you should have a wall. It cannot be only on the one side. Now we discussed that bottle trap should not be used simply because the seal depth will depend on where the plumber has cut this particular pipeline, and therefore it is prohibited tap. So you normally we see in common toilets situation like this. This is absolutely a wrong way. You will have to provide a proper so water traps or water seals and then only connect it. Avoid double trapping. So there is a trap for a basin and again it is connected to the P trap. That is not allowed as per the codes. You should have only one trap. Now you have to, the overflow of a tub bath, you cannot connect it after your trap, because in this condition there is no trap, and therefore every the foul smell, all bacteria will directly enter through your tub bath into your living space. So both these connections ultimately will get connected to a water seal or water trap, and then will get connected to the drainage system. When the fixture trap, not the stack, we have to trap the fixture, or we have to vent the fixture and not to the stack. Never use a T. This is a 90-degree T. This is a Y or swept T. Even swept T is better than the Y. Then you can always give a protection wherever your pipelines is passing through, any corridor for vehicular movement. Then there is a water hammer arrestor. There, if you suddenly close the wall or suddenly operate the water fixture, then there is a water hammer. So water hammer arresters should be used to absorb these water pressure waves and nullify the same. This is what is the sanitary separation. So this tank is totally separate. Even there is no common paddi. So even in leakage in the paddi will not contaminate the water. So you should not use any, this is particular water tank which is cleaning the urinals, and after certain time it is flushing the water. So even if somebody is not using it, it will consume the water and your water consumption will be more, so you should not use it. Now normally we use a point trap, floor trap, or a channel. Now whenever you use channel, you have to provide a single directional slope to your tiles, whereas in this particular case you have to give direction in slope in a different direction, and therefore to manage that entire slope is on this particular trap and no water is getting stagnant over here is difficult. So the best option is to use water channel, but those, as they are expensive, rarely people use it. So even in basin and everywhere, you have to use the air gap. You have to maintain the air gap so there is no water contamination. So thank you for patient listening. Is there any question? What is the problem with having multiple acha?
Rahul,
Yeah,
sir, this is Veerapan.
yeah.
Sir, good evening and a wonderful presentation, sir. Actually, very, very nice to move forward. Okay, I think really a lot of students have missed your presentation. It seems maybe around only 42 to 45 are participating in. Though we are very, struggling very hard, to pull the students. Students
Yeah.
show their color. That's it. That is what it happens. Okay,
Yeah.
only people like us, we have to push. At this juncture, again, I'm requesting all my NEC members to take this as a challenge to push the student chapter in all respects and see that all the students, at least 150 to 200 students should participate, including me, I'm talking about. Okay, sir.
Yes.
So having said all these things, one question is coming from that chat also you can see. Normally, students will never ask questions. You have seen.
Yeah.
Even at our college level also students will not ask any questions. Okay, coming back, two questions have come. One, what is the problem with having multiple traps? Because if one trap
Yes.
fails, we can have another backup. So that is the thing they were asking.
Yes.
Can you answer, sir?
Yes. See, when you have two traps, there is only a air in between the two traps. So when there is a higher velocity, it will in any case suck the trap. Secondly, if there are two traps, the velocity in the pipeline will decrease, and there is a chance that solid will get deposited in your trap, and therefore multiple traps are not permitted as per the codes.
I hope that student would have understood. The second question from Pramod Barde, how to avoid foaming near floor trap outlet for washing machine.
Yes.
That's a good question.
So there are different traps which are available for foam arrestor. So you can use those traps, but only the issue is you have to install it above the floor level, and therefore the washing machines which are totally automatic and water is discharged by a pump, then you can install it. So they will restrict the entire flow and they will allow only water to flow. This is the way you can avoid this foaming, which you will you see around your floor trap, where the foam is coming out of that floor.
Okay, I think Pramod would have understood. And sir, one more question from Ajay Kumar. I think it's a good question again. And when we instruct the contractor as an engineer, the labor will not follow the rules. What to do in these conditions to avoid?
Who is not following the rules? I didn't get you. Who is not following the rules?
That engineer instructs a contract. Instructor, that is the labor, no, the layman, when they instruct, they all think, plumber, the 20 years experienced plumber will think that he is doing the correct job. But when, new engineer instruct them, they will not follow. They will do on their own. How to overcome
there
that?
are only,
this is not technical question
there are
to be
only two ways. There are only two ways. First is you educate your plumber. If plumber understand what exactly is doing, if he is making mistake, how it is going to affect the health of the others, he will take care of all those issues. Because most of the people don't know, and therefore they continue to make mistake. And secondly, even your engineers should be trained enough. They should understand what exactly the technical realities behind it. And accordingly, they should be able to guide the plumber and they should be able to control it. Ultimately, it's a quality control job. So in any quality control, one has to be very vigilant, strict, and has to ensure that whatever the quality policy ultimately is there in place, one will have to follow it. But the education is the best way, because if someone understands what exactly he is doing, then he will do it in a better way.
I think one last question from my end, actually, sir. Actually, during the toilet planning, whatever we discussed here in the slides also, which
Yeah.
one you feel it is the sunken floor or it is non-sunken floor? Because in flat systems, sunken floor gives a good, approach. But when it comes to the core cutting and all, when somebody else stays in the flat in the bottom, they are not accepting it. Even yesterday, one case I attended, and there is a fight between the top tenant and the bottom tenant. There is a fight, which I was the mediator to solve the problem, but I could not solve the problem, to be frank, okay, because of the attitude. How to solve these things? Really, is it mandatory to go for sunken or through core cut?
See,
Only
no,
is ideal?
no,
Which
no,
one
no.
is
Therefore,
ideal? We can take it to the
therefore,
students.
I explained it when we discussed the sunken floor and ceiling hung piping. See, in both cases, the leakages will come at the bottom floor only. But if you have a sunken floor piping, you will be able to access and maintain the piping system through your toilet only. Otherwise, unless and until the top person is cooperating with you, you will not be able to handle that leakage. So, from my point of view, the ceiling hung piping is the best way. But what happens is that when you go for ceiling hung piping, the sound levels also go up, because when you are burying the pipe in the waterproofing, the sound gets absorbed. So that is the additional issue that you will have to tackle. But the more important issue is whether you are going for ceiling hung piping or sunken portion piping. Accordingly, what should be the beam depth from where your piping is entering into the shaft, that you have to decide it on day one. If my piping is coming from the bottom, then I have to restrict the depth to 450 instead of 600 mm. And if I'm taking the sunken floor, I will push down my beam, which will match to the sunken slab.
I think good, sir. I think we will stop here, because in another 5 minutes, if we speak, the participants' number will become 1. So let us close this with the vote of thanks. I think Mr. Milan is there. I'll proceed with the vote of thanks, Milan, with your permission. Milan Setti? Yeah. So, sir, Mr. Rahul, sir, and I think for the benefit of the students, wonderfully you have designed this, topic on this, plumbing practices, good plumbing practices. You have divided, I think, into 4 parts. If I correct me if I'm wrong: fixtures and fittings, sanitary drainage, water supply, and installation. Coming to the fixtures and fittings, you have covered in that, the standard dimensions, the distance, maximum flow rates, toilet planning, etc., etc. Wonderfully done for the benefit of the plumbing consultant as well as an architect. Those who the students wanted to be future, they want to be architect and or designer, they can follow this type of rules and regulations. Coming back to the sanitary drainage, wonderfully you covered the the traps, types of traps, prohibited traps, all those things covered in your PPT, including the sunken and non-sunken areas, and more particular traps for the fog end. Okay. And the part 3, sir, water supply, wonderfully you have covered, water quality, that about the walls and your specialized area, like I know you how special you are in water. I think definitely I hope students will put from here, and moreover, I wish they will be a an entrepreneur in future. And coming to the installation, puddle flanges, and do's and don'ts of the cementing and other systems and all have been covered. Very nicely you have covered, sir. Wonderful presentation, and thanks, Mr. Rahul Dhadphale. Thanks to Rahul Dhadphale, National Secretary of Indian Plumbing Association, and on behalf of Indian Plumbing Association. And thank you, sir. Thank you very much for this presentation. Thank you, sir. Thank you. Yes, sir. And coming back to the formal vote of thanks, thanks to my WPC chairman through video he has given. An important point message is plumber protects the health of the nation. Again, today also I'm quoting that, which is very vital to the today's topic. And thanks to Mr. Sanjay Bellary, Hyderabad chairman, for giving the wonderful welcome address. And of course, thanks to Ms. Santosh and entire HQ team for taking this seminar to the next level for the students. And thanks to student chapter convener, Mr. Milan Chetty, and team. Particularly, I'm talking about team because their team always calls and inquires and follow up was very good, and to make this seminar more success. Almost students are getting benefited, sir. All the people I'm just addressing here, students are getting benefited. Like the topics designed is something like that. Thanks to Milan Chetty, my convener, basics of plumbing, career opportunities, good plumbing practices, and tomorrow is a modern trends in plumbing. Who's going? Excellent consultant is going to cover that topic. Hope students tomorrow, a lot of students may join and I hope they will get benefited. And finally, thanks to NEC board and NEB board and all the staff at HQ, and particularly the students who are all presented today's seminar. I hope tomorrow also it will continue, and hope students will enjoy this session. Thank you very much, and thanks to my convener, Mr. Milan, for giving me an opportunity to be a part of giving this formal vote of thanks. Thank you all.
Thank you. Sure. Bye.
Bye.